Hello, I want to show you how to use SAS for doing simple linear regression. The task we will take up is we will use this dataset called auction dataset. This was downloaded from SAS website. Now this auction dataset contains data on cattle sales and cost of cattle, and we want to know if, and they're all numeric type data, we want to know if there is a linear relationship between cost and cattle. Okay, and so we'll kind of begin with trying to find out if there is any visual relationship that we can identify. So for that we'll do a scatter plot. Then following that, if we find there is some sort of relationship, then we could go ahead with computing what's called correlation coefficient. And then once you got that, then we'll go on to figuring out the linear regression. And once you got the linear regression model figured out, then we'll try and predict costs for some new cattle values. So that's a task. So let's go ahead and get started. Here's the SAS Enterprise Guide interface, and let's go ahead and open the dataset. I had already downloaded it, and it's available on my desktop, I believe. And so there it is, auction. Okay, there it is. So it's a small data set, only 19 observations. This is the same data set that is being talked about in the SAS's online training page. So if you go to SAS, I have a link to this page on Canvas, and so I used this page. You have something called simple regression, and so this is what I'm using auction markers and the number of cattle sold. Okay, alright, so here's the auction market. There's a number of cattle sold, and that's a cost. So we think there is a relationship between cattle and cost. Okay, don't worry about the units and all that, but we just want to focus on them. They're all numeric type data, and there are 19 different markets. Each market has a market ID, A, B, C, D, E, F, G, and so on. And there are, let's try and find out if there is a visual relationship between cattle and cost. So to do that, I'll use the graphing tool. In the graph, you have something called scatter plot. So scatter plot is pretty straightforward, simple to use. All you need to do is specify two variables and say which one goes on the x-axis and which one goes on the y-axis, and then it'll create the plot for you. You can take a look at it and see if there is any relationship. Okay, let's just choose a 2D scatter plot, and let's pick the data, and it needs vertical and horizontal, two columns required. On the horizontal, which is my independent variable, I'll choose cattle, and cost is going to be my vertical or the dependent variable. And other than that, I'm going to not worry about anything else. We'll go ahead and run this, and let's take a look at the results. The code, the SAS proc for doing a chart is proc gplot. Okay, and before that we already have assigned two columns and axis 1 is, let's see, sort temp, okay, sort temp table sorted. So that's what is created. So the first column is the cattle, and that becomes axle 2. I'm trying to find out where this assignment is being done. Okay, here you go. Axle 1 is tile 1, axle 2 is this. Okay, alright, let's take a look at the results. Okay, there it is. And so as the number on cattle axis increases from 0 to 2 to 4, 6, 10 and so on, the corresponding y value seems to increase. So there seems to be a relationship as it kind of goes up, but it seems to curve up a little bit. There is 1 point above 14, cattle 14.3 and cost 101. That's really way out there. It doesn't seem to really be part of the rest of the group, but you know, there's only one data point. Okay, so but overall there seems to be a kind of a relationship. As cattle increases, the cost also increases. Alright, so now that we know there is a relationship, let's go ahead and see if we can quantify this relationship between cattle and cost. So to quantify the relationship, let's go to process flow, and we're going to run a correlation. So analyze, let's say it should be under okay, describe. It's under multivariate correlations. Now correlation is it's a important concept, and for interpreting relationship between variables. And we're going to, this is the notes from another class I taught earlier. A correlation coefficient is it's a number that can take value between -1 to +1, and it is it has no dimension. It's a pure number, and any value that's closer to -1 includes a strong negative linear relationship, and any number that is close to +1 indicates a strong positive relationship. Okay, so positive relationship means as x increases, y also increases, and negative relationship means as x increases, y decreases. Now if the correlation value is closer to 0, then the relationship is really weak. Okay, so you want correlation coefficient that is high, either it's negative or positive, doesn't matter. If it's above 0.5, 0.6, 0.7, 0.8, that's really good. -0.8, -0.6, -0.7, -9.9, that's good. Good to have those relationships. Okay, and so let's see how we can do that using SAS. So under SAS, I choose analysis variables, and let me pick cost is my analysis variable, and cattle is going to be my correlate with. Okay, so it doesn't matter if I have cost here and cattle and cost, and replace, switch around, it'll still come back with the same correlation coefficient. And it'll also you can also optionally ask it to show covariance and so on. Okay, it can also do a scatter plot right here. I could have done this using the correlation feature of SAS. Okay, and let's go ahead and run this. Okay, here we have it. We got the results, and it also shows you the mean, standard deviation, and the summary statistics for both variables. And also notice the correlation coefficient is 0.88, which is good, which is pretty good actually, and it's close to 1, and it's suggesting a positive, strong positive relationship. And this particular variable, this coefficient is it's also significantly different from 0. So the p-value associated with that coefficient, correlation coefficient, is really small. So since the p-value is less than our alpha of 0.05, I would say, let me favorite to write notes about it. Okay, I would write notes such as um, correlation coefficient is high and I'm positive, suggesting a strong positive relationship. It is significantly different from 0 because our p-value is less than 0.001. As then that means reject the null hypothesis that correlation coefficient equals 0. Okay, alright, so that is good news. And now that we know the correlation coefficient is strong, let's go ahead and do the linear regression. Okay, so let's switch to process flow and I choose analyze, regression, linear regression. Okay, so cost is going to be our dependent variable and cattle is going to be our explanatory variable, and the model, a full fitted model, no selection. Statistics, don't worry about the statistics right now. And it's going to give a whole lot of plots, and I think I'll just choose a residual plot and residual by predicted values. I'll use that. Okay, and predictions, we'll come back to this in just a minute. We want to be able to predict for some other values, so let's go ahead and run this. Okay, here we have the results of a linear regression, and okay, now the results, essentially it uses variance analysis of variance technique to find out how much of the variance in the dependent variable is described or describable by the model, and it comes back with an f value high enough for probability being, probability of the null hypothesis being true is really small, so we reject the null hypothesis. Now what is the null hypothesis here? The null hypothesis is that the model, the results are not significant. Okay, now what does that mean? Let's see. Now if you look at the model itself, the model is made up of two things. Your intercept and the variable. So intercept is the first thing, and the intercept, we are not going to worry about the intercept, but the second part of the parameter estimate is cattle, and that is significant at alpha of 0.05 level. So this slope that we see, 4.56, that is significantly different from 0. That's what the small probability means. Since the slope is significantly different from 0, the overall model is also significant. Okay, so we are able to come up with the linear regression model with 7.19 as the intercept and 4.56 as the slope. Very well. So now that we have our model, let's take a look at what's called the residual plot. Now residual plot basically tells you the distance. Residual means the distance between the predicted y and the actual y. Okay, and the predicted y and the actual y, and does it significantly vary across predicted values? And these data points are mostly on both sides of the zero line. So when you have a residual plot, you want the residual plot data points to lie along on both sides of the zero line, so that is good. But there are some points that are consistently below the zero line, especially for high values of predicted value. Okay, and that may be a little concern, because maybe that we are missing some data points, or if we had extra data points it might look different. Okay, overall I'm not unhappy with this, so that is good. All right, next step is to try and use this regression coefficient, or the slope and the intercept, to predict values for new set of variables, new set of values, okay, new set of values of cattle. So let's go back to the model, and I'll modify this. There is a way to specify prediction. Okay, before we do that, let's take a look at another data set that I think is available here. Should be okay. It's possibly stored as part of the project. Forget it. Let's go back here. Let's go modify linear relationship. And let's see predictions. Let's choose additional data and choose browse. Okay, and on my working folder I have this auction 9063 file, so I'm going to open that. Now that's got the same sort of columns as the original data set. Okay, and so let's try and use that to predict cost for new cattle values. Go ahead and run this. Alright, so it looks like it's done, and let's go back and take a look at our process flow. There is a linear regression predictions. Let's take a look at the output of the predicted values. Okay, now this one we have the cost original. These are cattle, and that's the original cost, and that's the predicted cost. So this, how did you figure this predicted cost? Remember the constant and the intercept, this constant and the slope we calculated from regression model. We use that to calculate this number. Okay, so that is again go back here. Intercept is so if you were to write a formula for that, it would be let's say for the very first predicted value, cattle is 3.437. And we calculated the intercept to be 7.19. So predicted value of cost predicted cost is 7.19 650 plus the slope is 4.56396. The cattle is 3.437. Now if you do the math here, let me see, let me use my calculator. Okay, let's do the product first. 56396. 396 times 3.437 plus 7.1964, 7.1965, 22.88. So that's 22.8828. 8828. Okay, let's see if that matches the number from our result. There it is, 22.8828, 22.8828. So these are the predicted values of cost based on this cattle values. Okay, so that's how we can use linear regression, a simple linear regression, to predict new values of for new values of the independent variables. All right, thanks.